Alright, let's dive into Module 1 where we'll be exploring the world of Docker. So, first things first, what exactly is Docker and containerization? Well, Docker is a tool that allows you to package and run applications in a container, which is like a lightweight, standalone, executable package that includes everything needed to run the application. Pretty cool, right? Now, why should we bother using Docker? The benefits are pretty significant. It helps with consistency across different environments, makes it easier to deploy and scale applications, and increases efficiency by reducing the overhead of virtual machines. Moving on, let's talk about the architecture and components of Docker. It's made up of a few key parts, like the Docker engine, which is responsible for building, running, and distributing containers, as well as Docker images, which are like blueprints for containers. So, to sum it up, Docker is a game changer in the world of software development and deployment. It's all about packaging applications in containers for easier management and increased efficiency. Exciting stuff, right? So, let's talk about Docker. It's like your virtual toolbox for developing, shipping, and running applications. Picture containers as these neat little packages that include everything your software needs to do its thing: code, tools, libraries, you name it. Containerization is the magic trick that turns your app and all its buddies into these portable, easy to deploy packages. And Docker? Well, it's the master of containerization, making it a breeze for developers to create, test, and launch their apps without breaking a sweat. Cool, right? So, picture this: you're a developer working on a web app, and you want an easy way to share your work with your team and deploy it without any headaches. Well, that's where Docker comes in. With Docker, you can bundle up your app, along with all its necessary bits and pieces like databases and settings, into a neat little container. This container can then be passed around to your team, deployed on different servers, or even fired up on your own computer without any compatibility woes. Basically, Docker takes the hassle out of managing dependencies and ensures that your app runs smoothly no matter where it ends up. It's like having a magic box that makes developing and deploying apps a breeze. Pretty cool, right? So, picture this: you've got a DevOps team working on deploying a bunch of microservices in the cloud. How do they keep things organized and running smoothly? Well, that's where Docker containers come in. With Docker, each microservice gets its own little container, which means they can all operate independently. This not only helps with using resources more efficiently, but it also makes scaling up a breeze and keeps management simple. By containerizing with Docker, teams can streamline the whole process of building, testing, and deploying apps. This leads to quicker development cycles and better teamwork between developers and operations folks. Pretty neat, huh? So, when it comes to using Docker for containerization, there are actually quite a few perks to consider. One of the big ones is how portable Docker containers are. They can run on pretty much any platform that supports Docker, which makes it super convenient for deploying applications across different environments. Plus, Docker is all about keeping things consistent. By bundling applications and dependencies together, you can be sure they'll run the same way in development, testing, and production. And let's not forget about scalability and resource efficiency. Docker makes it easy to scale up and down quickly, and it helps you make the most of your infrastructure resources. So, all in all, Docker is a real game changer in the world of containerization. So, imagine this: you've got a company using Docker for its applications. With Docker, you can easily move those apps from your on-premises servers to the cloud without having to mess around with the code too much. It's like a breeze, right? This flexibility and portability comes in handy when your business needs to adapt to new requirements or scale up your applications. Plus, Docker is super lightweight and efficient, so you can save some cash by running more containers on the same hardware. Pretty cool, huh? So, Docker has this cool feature that really helps out developers. It lets them work in their own little bubble, free from any pesky conflicts or compatibility problems. This means they can focus on their work without getting bogged down by technical headaches. Plus, Docker makes it super easy to create, test, and share their work with others. All of this adds up to faster development and better teamwork. Basically, Docker is like a secret weapon for modern software development. It's a game changer, for sure. Hey there. Welcome to Module 2 of our Docker tutorial. Today, we're going to dive into getting started with Docker. We'll cover some essential topics like installing Docker on various operating systems, running your very first container, and exploring some basic Docker commands and operations. So, let's kick things off by talking about how to install Docker on different operating systems. Once you've got that set up, we'll move on to running your first container. This is where the magic happens. You'll see how easy it is to get started with Docker. And finally, we'll take a look at some Docker commands and basic operations. Don't worry, we'll walk you through everything step by step, so you'll be a Docker pro in no time. So, grab a cup of coffee and let's get started with Module 2, Getting Started with Docker. Let's do this. So, if you're looking to get started with Docker, the first step is to install it on your computer. Whether you're rocking Windows, Mac OS, or Linux, Docker has got you covered. Each operating system has its own unique installation process, but don't worry, it's all to make sure Docker runs like a dream on your machine. Getting Docker up and running is key if you want to start using containers and reaping all the benefits of containerization. So, let's dive in and get Docker installed on your system. Hey there! If you're a Windows user looking to dive into Docker, Docker Desktop is the way to go. Just head over to the official Docker website, download Docker Desktop, and follow the installation wizard to get it all set up on your machine. And for all you Mac OS users out there, installing Docker Desktop for Mac is a breeze. Just grab the installer, run it on your computer, and you'll be good to go. Now, Linux users, don't worry, you haven't been forgotten. You can install Docker Engine by checking out the installation instructions on the Docker website that match your specific distribution. So whether you're on Windows, Mac OS, or Linux, getting started with Docker is just a few clicks away. Happy coding! So, you're ready to dive into the world of Docker and run your first container? Awesome! Containers are like these super cool, lightweight, and portable environments where you can run your applications hassle-free. No more stressing about dependencies or compatibility issues, it's like a stress-free zone for your apps. To kick things off, you'll need to grab a Docker image from the Docker Hub repository. This image comes fully loaded with all the software and settings your container needs to run smoothly. It's like getting a pre-packaged kit for your container adventure. So, go ahead and pull that image, and let's get this container party started. So, if you want to dip your toes into the world of containers, you can start by running a simple one. Just type in the command docker run hello world and hit enter. This will grab the hello world image from Docker Hub and fire it up as a container on your computer. You'll get a little message letting you know that everything is running smoothly. It's a great way to get a feel for how Docker works and dive into what containerization can do. Give it a try and see where it takes you. Alright, so you've got Docker up and running and you've launched your first container, great job. Now, let's dive into some essential Docker commands and basic operations to really get the hang of managing your containers like a pro. Docker offers a whole bunch of commands that let you do things like building, running, stopping, and removing containers, as well as handling images and networks. Getting a handle on these commands is key to smoothly navigating the world of Docker and handling everyday tasks with ease. So, let's roll up our sleeves and explore these commands to level up our Docker game. Alright, so let's talk about managing containers in Docker. One handy command you can use is docker ps, which will show you all the containers currently running on your machine. If you need to stop a specific container, you can use docker stop container_id, where you replace container_id with the actual ID of the container you want to stop. And if you want to remove a container that is already stopped, you can use docker rm container_id. By getting comfortable with these basic Docker commands, you'll be able to handle containers like a pro and make your development process much smoother. So go ahead and give these commands a try to see how they can help you in your container management tasks. Alright, so in Module 3, we're going to dive into working with Docker images. First up, we'll chat about what exactly Docker images and containers are all about. Then, we'll get into the fun stuff, creating our very own custom Docker images. And finally, we'll explore how to use Docker Hub to easily pull and push images. So, let's get started and learn all about working with Docker images. Alright, so let's talk about Docker images. Think of them as the blueprints for building Docker containers. Basically, they're like the building blocks for running software. These images are super lightweight and contain everything needed to run a piece of software, like the code, runtime, libraries, and dependencies. Now, here's the cool part, images are created using layered file systems, which helps with efficient storage and makes for speedy container startup times. Containers, on the other hand, are instances of these Docker images that can be run on a host machine. They basically wrap up the application and its dependencies, providing isolation and portability. So, to sum it up, Docker images are like the ingredients for making containers, which are like little packages that hold all the necessary components to run your software. It's a pretty neat system that makes managing and running applications a whole lot easier. So, let's say you've got this cool web app you want to run in a Docker container. The first step is to put together a Docker image that includes all the important stuff, like the code for your app, the runtime environment it needs, like Node.js or Python, and any libraries or dependencies. Once you've got your image ready to go, you can fire up multiple containers, each one running a separate instance of your web app. And here's the really neat part, these containers are totally separate from each other and from the host system, which means your app will run smoothly no matter where it's deployed. Pretty cool, right? So, when it comes to Docker, creating your own custom images is where the magic happens. It's like crafting a unique environment just for your apps and services. You start with a base image as your foundation and then layer on all the extra software, settings, and app setups you need. And the key to this whole process? That's right, the Docker file. It's basically a text doc full of instructions for building your custom image. Following these instructions automates the whole image making process, making it a breeze to recreate and share your custom environment across different setups. Pretty neat, huh? So, let's say you want to whip up a custom Docker image for your Python web app. The first step is to grab a base Python image from Docker Hub. Next, in your Docker file, you'll specify that base image, toss in any extra dependencies with pip, drop in your app's code, and open up the necessary ports for communication. Once your Docker file is good to go, you can fire up the Docker build command to bring your custom image to life. This unique image is now ready to spin up containers running your Python web app smoothly and consistently. Cool, right? Alright, so let's talk about Docker Hub. It's basically like a big online storage space where you can keep and share Docker images. Think of it as a virtual library full of all kinds of images created by different people or organizations. When you need a specific image, you can just hop on over to Docker Hub and download it to your own computer. This way, you can use it to run containers based on those images. And hey, if you've created your own cool image, you can upload it to Docker Hub too. This lets other folks access and use your image for their own projects. Pretty neat, right? So, Docker Hub is like the go-to spot for all your Docker image needs. So, let's say you're looking to use a MySQL database in your project. One way to do that is by grabbing the official MySQL image from Docker Hub. Just use the docker pull command to download it onto your machine. Once that's done, you can set up a container with that image and get started with MySQL. On the flip side, if you've got a custom image for a Node.js app that you want to share with others, you can easily push it to Docker Hub using the docker push command. This way, your custom image becomes available for anyone to download and use in their own projects. It's a great way to share your work with the world. Alright, in Module 4 we're diving into Docker networking and volumes. We'll be covering some important topics like Docker networking concepts and configurations, managing data with Docker volumes, and connecting containers with each other using networks. So, let's start with Docker networking. This is all about how containers communicate with each other and the outside world. We'll look at different configurations and how to set them up. Next up, we'll talk about managing data with Docker volumes. Volumes are a way to persist data even if a container is stopped or removed. We'll explore how to create and manage volumes to make sure our data is safe and accessible. And finally, we'll discuss connecting containers with each other using networks. This is crucial for applications that require multiple containers to work together. We'll go over how to set up networks and connect containers seamlessly. By the end of this module, you'll have a solid understanding of Docker networking and volumes, and be equipped to efficiently manage your containers and data. Let's dive in. Hey there. Let's talk about Docker networking, which is basically how containers chat with each other and the big wide world outside. By default, Docker keeps containers in their own little bubbles, but networking lets them break out and connect. It's like building highways for containers to share stuff and work together. Docker offers different network drivers, like bridge, overlay, and host, to help containers and the host machine talk to each other. These drivers have their own special purposes and settings, depending on what your app needs in terms of networking. So, in a nutshell, Docker networking is all about creating connections between containers and the outside world, using different drivers to make it happen smoothly. So, let's say you want to set up a bridge network in Docker. All you gotta do is type in the command docker network create my bridge network. This command will basically create a cool new bridge network where all your containers can hang out and chat with each other. Once you've got that set up, you can run a container and connect it to this network by adding the -network my bridge network flag when you launch the container. This way, your container can easily talk to all the other containers on the same network. Cool, right? Just a simple command and you've got your containers networking like pros. Hey there. So, Docker volumes are basically a cool way to keep all that important data safe and sound from your Docker containers. Instead of having everything stored inside the container, volumes let you store data outside the container's file system. This makes it super easy to manage and share data between different containers. Volumes are like your best friend when it comes to storing database files, logs, and any other data that needs to stick around even if your container decides to take a little nap and restart. You can create, list, and remove volumes using nifty commands like docker volume create, docker volume ls, and docker volume rm. So, volumes are definitely a handy tool to have in your Docker toolbox. So, let's say you want to set up a volume in Docker, right? All you gotta do is type in docker volume create my data volume and boom. You've got yourself a brand spanking new volume ready to be attached to any containers you fire up. When you're running a container, just throw in the v flag and specify the volume name and where you want it to be mounted in the container. This way, the container can access and store data on the volume, even if you shut it down or delete it. Cool, right? It's like having your own little storage space that sticks around no matter what. Hey there. So, let's talk about Docker networks. These networks basically allow containers to chat with each other, which is super handy when you're building more complex applications with lots of interconnected containers. By hooking up containers to the same network, they can easily talk to each other using their container names as if they were host names. This makes setting up communication between containers a breeze, without having to expose ports externally. Plus, connecting containers using Docker networks adds an extra layer of security and isolation by keeping all the communication within the network boundaries. Pretty cool, right? So, let's say you want to set up a network in Docker, right? Well, all you have to do is run the command docker network create my app network. After that, you can start running multiple containers and link them to this network by using the -network my app network flag. This way, the containers can chat with each other using their cute little container names as host names. It's like they're best buds now, making it super simple to connect different parts of your application. Cool, right? Hey there. Today, we're diving into Module 5, where we'll be talking all about Docker Compose and orchestration. So, let's get started. First up, we'll take a look at Docker Compose. This tool is super handy for creating multi-container applications. It helps you manage all the different services and dependencies in your application with ease. Next, we'll explore how to actually create those multi-container applications using Docker Compose. We'll walk through the steps and show you just how simple it can be to set everything up. And finally, we'll touch on container orchestration tools like Docker Swarm and Kubernetes. These tools help you manage and scale your containers across multiple hosts, making it easier to handle larger, more complex applications. So, whether you're just getting started with Docker Compose or looking to dive into container orchestration, we've got you covered in Module 5. Let's get learning. So, have you heard of Docker Compose? It's this awesome tool that makes running multi-container Docker applications a breeze. Basically, you can define all your services, networks, and volumes in a simple YAML file. And get this, with just one command, you can spin up a whole complex application. It's perfect for when you're developing or testing stuff. Plus, it keeps everything consistent across different environments by putting your entire application stack in one neat little file. Cool, right? Alright, picture this, you've got a web app with a front-end server, a back-end API server, and a database. Now, with Docker Compose, you can simplify things by creating a dockercompose.yml file. This file spells out the services for each part, the networks to link them up, and the volumes to keep your data safe. So, when you fire up Docker Compose up, Docker Compose swings into action, firing up all the containers and setting up the network and volumes just like you specified in the YAML file. Cool, right? Have you ever heard of Docker Compose? It's a handy tool that lets you easily manage multi-container applications all in one place. With Docker Compose, you can define your services, set up dependencies, and link containers together, all in a single file. This makes it a breeze to spin up and tear down complex environments whenever you need to. One cool thing about Docker Compose is that it simplifies the deployment process for applications that rely on multiple interconnected containers, like those in microservices architectures. And if you ever need to scale up your services, Docker Compose has got you covered. With just a single command, you can run multiple instances of a container, super convenient, right? So, whether you're a seasoned pro or just starting out, Docker Compose is definitely worth checking out for streamlining your development workflow. So, picture this, you've got a bunch of different services in your microservices setup, like authentication, user management, and notifications. With Docker Compose, you can neatly outline each service in a handy dockercompose.yml file and spell out how they need to chat with each other. When you're all set up, just fire up Docker Compose up to kickstart all the containers and watch them seamlessly interact based on the settings you've laid out in the YAML file. Cool, right? Alright, so let's talk about container orchestration tools like Docker Swarm and Kubernetes. These tools are super handy for managing and scaling containerized applications across multiple machines. They come packed with cool features like automatic load balancing, service discovery, and self-healing capabilities to make sure your containers are always up and running smoothly. Now, Docker Swarm is like the UG of orchestration tools, built right into Docker itself. It lets you manage a whole bunch of Docker hosts as if they were just one big virtual host. On the flip side, Kubernetes is like the fancy big brother, developed by Google. It's a more advanced tool that gives you a powerful platform for automating the deployment, scaling, and management of your containerized apps. So, whether you're using Docker Swarm or Kubernetes, these tools are a game changer when it comes to keeping your containers in check and running like a well-oiled machine. Cool stuff, right? So, picture this, you've got this massive application that needs to have multiple instances of containers running on different nodes. It's a pretty complex setup, right? Well, that's where Docker Swarm or Kubernetes come in to save the day. These tools basically help you orchestrate the whole deployment and scaling process of your containers. Instead of manually managing everything, you can just define how you want your application to look in some configuration files and let the orchestration platform do all the heavy lifting for you. It takes care of deploying and managing those containers automatically, making sure your app stays up and running smoothly, even when things get a little crazy with failures or a sudden spike in traffic. So, it's like having your own personal team of container wranglers keeping everything in check for you. Cool, right?
If you liked this tutorial video, please like, share, and subscribe to the channel. Until next time.